Chapter 9 Applications of Integrations. Example 9.21 Alternate method. Evaluate integral 0 to pi x by 1 plus sin x dx. Solution. First write the given question as I is equal to integral 0 to pi x by 1 plus sin x dx. So we know that one property, we know that integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Look the integral, it is of the form 0 to something, that is 0 to a. Here our a is a pi. So first the given question is a, take number 1 equation. Now replace this x by a minus x, that is pi minus x. Therefore our I is equal to 0 to a, the right hand side. The left hand side is a given question. Now write I is equal to right hand side of a property 0 to pi a minus x. Therefore replace x by pi minus x. Replace this x by pi minus x. Therefore this x place we can write pi minus x. 1 by 1 plus sin pi minus x into dx. This is equal to 0 to pi minus x 1 plus sin 180 minus x is sin x. By all silver teacups rule we get sin pi minus x is equal to sin x into dx. This is I is equal to this, equal to, take number 2 equation. So now adding 1 and 2. Now adding 1 and 2, this is 1 plus 2. We get in left side I plus I equal to 0 to, write the term as it is, 0 to pi x by 1 plus sin x dx plus, here write the right hand side 0 to pi minus x by 1 plus sin x dx. So look the integral, both are same limits. Therefore write the integral as a common 0 to pi and write the terms inside the integral. So here denominator 1 plus sin x, here also 1 plus sin x. Therefore common denominator 1 plus sin x. Just add the numerator x plus pi minus x into dx. Now this x plus x minus x get cancelled. In left side we get I plus I is equal to 2i. This is equal to integral 0 to pi by 1 plus sin x into dx. Pi is a constant, take outside, is a pi. Integral 0 to pi 1 by 1 plus sin x into dx. Now this is equal to the left side is a 2i. This is equal to pi into 0 to pi 1 by 1 plus sin x. This term is multiplied and denominator with 1 minus sin x into dx. This is equal to pi into 0 to pi, just multiplying both numerators, we get 1 minus sin x, and both the denominators is of the form a plus b, into a minus b equal to a square minus b square. Here 1 minus sin square x into dx. This is equal to pi 0 to pi 1 minus sin x We know that 1 minus sine square x is a cos square x into dx. This is equal to pi. Inside the integral there are two terms. We can split into two separate integrals, that is 0 to pi. This pi is a common for both terms. 0 to pi 1 by cos square x minus this term sin x by cos square x. Here dx 0 to pi dx. So two separate integrals. So now this is equal to pi into 0 to pi 1 by cos square x is a secant square x dx minus this term sin cos square x is a cos x into cos x. Sin by cos is a tan. So 0 to pi tan x into 1 by cos is a secant x dx. In next line, apply the integral formulae. We get pi secant square x derivation, secant square x integration is a tan x. So tan x, and apply the lower upper limit minus into tan x secant x integration is a secant x. Secant x, the limit is over 0 to pi. Here we use the formulae or applied integral formulas are, the applied integral formulas are integral secant square x dx equal to tan x plus c. This is one. The other is integral secant x into tan x dx equal to secant x plus c. These two are applied here. This is equal to, now apply the upper limit and then lower limit. So pi, so tan pi minus tan 0, close it, minus secant pi minus secant 0 and close the bracket. Secant 0. This is equal to pi. We know that tan 180 is a 0 and tan 0 is also 0, minus secant 180, the value is minus 1 and secant 0 is 1, close it. That is not necessary for the right term, it is 0. So pi minus 1, it is minus 2, and multiply these two, we get plus 2. That is plus 2 pi. In left hand side our term is 2i. So 2i is equal to 2 pi. Therefore I is equal to 2 pi by 2. We get pi. This is equal to pi. Therefore the integral 0 to pi x by 1 plus sin x dx is equal to pi. This is the correct answer. Integral 0 to pi x by 1 plus sin x dx is equal to pi. Therefore, example 9.21 alternate method is also over. Thank you.